Hi, hello everyone. Welcome to Vision classes. It's classes for IGCSE, GCSE student. So today we have to discuss the IGCSE Physics, Thermal Physics part, some of the MCQs from past year paper. So these are the questions that gives us the better idea of what kind of questions you are getting in the thermal physics from the thermal physics part in MCQ paper. All right. So first question we have here is that which graph shows the volume of a fixed mass of gas at a constant temperature varies with pressure. Fine. Here this is question relating to the Boyle's law. We have Boyle's law which states that the fixed mass of gas at a constant temperature, pressure and volume are inversely proportional. Fine. So P is inversely proportional to 1 upon V. This means pressure increases, volume decreases, or vice versa. Fine. So we'll analyze the four graphs, okay, and we will come to the conclusion for the answer as well. Okay, so A graph shows that the volume here on the y-axis, pressure on the x-axis, and the volume increases as pressure increases. So this is definitely not an inverse relation. So this one is not correct, right? Then nextly the graph here in the second part, volume and pressure. Here this is linear relationship between the pressure and doesn't make sense. So this is also not an inverse relation. C part here the volume as volume increases the pressure decreases, right? So this shows that decreasing volume with increasing pressure, but this is linear decrease. Fine. So it's an inverse relation which is not really, but in Boyle's law it's a not linear one. So in the C is also not correct one. Fine. And then we have left with the last one, which is inversely proportional. The as pressure increases, volume drastically decreases as well. So this is the correct answer. Fine. So yeah, our regular classes, batches, and all those things are going on. Suppose if you want to continue with us to know these kind of tips and tricks to understand all the basic laws like that, I have left the contact in the description box as well. So next question is basically which effect is caused by the thermal expansion. So thermal expansion basically tendency of the matter to change volume in response to the change in temperature. Means as temperature goes up or heated, right, the particle move more vigorously, right, and increases the average, means it's a average space between the particle increases that lead expansion in size. Fine. So we'll analyze one by one the options. First one is metal surface heating up in direct sunlight. So when metal surface does not heat up due to absorbing the solar radiation, so this does not change the size due to increase in temperature. Fine. And this is thermal expansion consequence of heating. Fine. Then nextly, ice cream melting on hot day. Fine. The melting is basically change of state from solid to liquid due to increase in temperature. And so the change in the arrangement of the and the movement of molecules. Okay. Then C part, railway track buckling on the hot day. So this is means railway track is made up of a metal, so expand when heated by the sun on hot day. This is more specific, right? And this basically expansion can cause the significant stress. Fine. So buckling can take place. So this is the right option we can say. Fine. And ice formation on a pond on cold day. This is actually not an expansion. We can say contraction even. Okay. So this is also not option. So correct option is C. Then temperature of water at the bottom of the waterfall is greater than the temperature of water at the top. Fine. So this is, let's say, waterfall. Temperature here is greater than the temperature at the top. Fine. Let's say at the bottom, and here temperature at top. Fine. So energy in the gravitational potential store of water at the top transferred to the temperature store at the bottom. So temperature difference we have to calculate in this case. So to calculate this temperature difference, we have to use the formula. So which is here, first of all, the temperature difference of waterfall at the here the height is given 21 meter. So we can calculate the energy stored at the top. Fine. So it is E is equal to potential energy is equal to mgh. Fine. So it is equal to here, let's say 1 times G is 9.81, H is 21. Fine. So we will get the 206.01 joule, right? And now we can use the same energy. Q is equal to mc delta T. Fine. So see, Q here is nothing but just a whatever the energy we have got here. So it's a 206.01 is equal to 1 times C is 4200 times delta. Fine. And then we will get the Q is equal to 206.01 divided 4200, isn't it? And we will get 0.049 approximately degree Celsius. Fine. And the correct answer is B. Getting it? I will explain it quickly once again. So energy stored at the top is equal to the temperature difference we will get generally. Fine. And that is what we have to here calculate. Yeah. Then the next one, the ice cube is placed in the beaker and heated. The ice melts from the form water, which evaporate first and then boils. The steam condense on cold window room, which process involves the transfer of energy, ice, water, or steam surrounding. So we have to explain the just a energy transfer. So see, first of all, here melting, evaporation, boiling requires energy input right from the surrounding, isn't it? And the condensation means that releases the latent heat to the surrounding. So the right answer is D, because this three process in which energy input is required. Fine. And in the condensation process, energy released to the surrounding. That's a difference. Okay. So we will get the straight away answer. That's a D. I hope you got all these answers. Fine. To know these kind of tips and tricks, share and subscribe to our channel as well. Thank you. Enjoy the physics.